Hi, I'm Mark Horn. I'm from Cubic Defence Australia. Cubic is a provider of simulation systems and services. We support the Australian Defence Force with command control, computers, communications, intelligence, surveillance and reconnaissance solutions, as well as simulation. So we first received a contract for the Combat Training Centre instrumentation system in Townsville in 2006, and also a contract with the Royal Australian Air Force. So we commenced an Australian entity, Cubic Defence Australia, in 2007, and we've been in Townsville since then. We now employ about 60 people here in Townsville, a broad range of skill sets, and we support the Australian Army predominantly, with the Combat Training Centre being our key customer here in Townsville. So in defence industry, I think there's an insatiable appetite for STEM skills. If you are good at science, technology, engineering and mathematics, and you can demonstrate that in a career pathway, you will be able to be employed in defence industry for sure. In Cubic, we have a strong workforce that's core skills are built up around STEM. But we also have a whole bunch of people that are just good at understanding what customers require and at directing the delivery of STEM-related skill sets to solve people's problems. And those people are just as important, have just a stronger place in the defence industry as those that can practice the more technical skill sets. You may start a career in an area, say for example as a technician, and end up in a very specialised engineering role. We see that in Cubic with people that started perhaps with an information communications and technology background, and all of a sudden they become a simulation professional, and then they look at data translation and data normalisation. They may end up becoming someone like a data scientist down the track, or a network engineer. So we're going to see that occur definitely in the future with STEM. I think that we'll also see it becoming more embedded within all of the technology and applications and things that we use in everyday life. And so having an inherent understanding of that is something that we should just have a go at and try and be as good as we can. Yeah, I think we have people in Cubic that perhaps every day in their lives they say, gee, I never thought I would have been doing this when I grew up. We have people that are electronics technicians, network engineers, systems engineers, very traditional STEM background type roles. But then we have other people who have come into roles of analytics or art, the application of art to animations, which then becomes simulations. In Cubic, we make and create and support games, but these are serious games for the purposes of preparing Australian Defence Force warfighters to go overseas and to perform missions here in Australia. And so there's a whole number of different skill sets, from animators to data scientists, that we wouldn't have normally thought about, that are actually preparing these systems that support the ADF and what they do. Mathematics, physics, chemistry and other physical sciences, including business type studies, all have application in the real world, even if you can't see it straight away. The most important thing is it may be hard, it may challenge you a great deal, but you will pick up basic understanding of, say for example, the physical principles of how things work. And if you do that, then much later on in your life, you may not have to solve a problem technically. You might have people that can do that around you in your work team, but you understand that that problem can be solved by a technology. You know who to go to and how to make it happen. And that's a really important skill to have later in life. So I'd say have a go.